Hello YouTubers and fellow hams. Well, one of the things that I want to try to do this summer that I haven't done yet is make contact through a satellite, be it the ISS or one of the many amateur satellites that are in orbit presently. Now to do that, I'm going to want to use Gpredict, which is the free and open source satellite prediction software seen here. It has facilities in it for controlling the frequency of your radio to compensate for Doppler shift, and it has facilities for controlling a rotor if you have an automatic antenna that you want to have tracking the satellite. I don't have that. In fact, antenna is the one area that I'm kind of restricted at the moment. All I have really for VHF, UHF is my Slim Jim, which is a vertical variant of the J-pole antenna. I can pick up satellites okay with it, but it's not really optimal, so I'm going to have to work on that. But right now, I'm going to work on Gpredict and having it controlling the frequency of my transceiver. In the past, I've done a video where I used Gpredict to control the frequency of the SDR receiver GQRX for automatically capturing weather satellites. So I know kind of how it works, but getting it to control your transceiver is a couple of extra key components that are involved in doing that. So that's what we're going to walk through. Now, Gpredict's facility for controlling radios and rotators works through a network interface. It talks through a network port on the networking stack in the operating system to another IP address or another program running on the same computer using the localhost address. The advantage to that is that GQRX can be on one computer and your control software can be on another computer across the network, even across the internet. So that's kind of a cool thing, but we're going to be doing it all on the same computer. And there are a couple of extra components that are involved in the chain of command between Gpredict and your radio. So the way it works is Gpredict has a standard set of commands that it uses that are understood by rigctl, which is a program that comes with hamlib. It's starting to sound complex, but it's really not too terrible. It's really kind of easy. So the chain of command is Gpredict sends commands through the network stack to a piece of software called rigctl, or rigctl, that is a daemon that's running in the background. And that program receives those commands from Gpredict and then talks through hamlib to your transceiver. Now, hamlib is a library that translates a standard set of control commands to the specific instruction set, command set that each different transceiver utilizes. Every manufacturer has their own method and their own protocol for controlling their radio through a serial connection. Hamlib understands all those differences and then has a translation from a standard set of commands. Now, Gpredict has an excellent manual, as we can see here, and Chapter 7 is all about controlling the radios, and they walk you through the whole process step by step, and that's what I'm going to walk you through here today. So let's go to the computer, and what we're going to do is we're going to set up hamlib, rigctl daemon, and Gpredict, and I'll show you it controlling my transceiver. Now, under Linux, I like to use Synaptic Package Manager for installing and uninstalling software when I'm doing it directly. Inside Synaptic Package Manager, you're going to want to search for rigctl. Here's my results, and the two things we're going to want to install here is Gpredict. So you'll check this box, mark for installation. I've already got it installed, that's why it's green. And libhamlib-utils, which will install the daemon and the other utilities and the hamlib library itself. So you should have those two installed. Also, I'm going to presume in this video that you already have serial working and you've already set up something like FLDigi or WSJTX, so you already are able to communicate with your radio. If not, there are a couple of different things you need to do, and I will link a video in the description, which is primarily about installing Chirp Next, but it talks about the two things you have to do to get Serial to work. So you might have to do that. Once you've got the software installed, we're going to have to figure out what serial device your radio uses, and then we're going to have to figure out what type it is in hamlib. Hamlib has a type number that it uses to index the different radios, and I'll show you how to find that in a moment. First off, serial ports. You're going to want to open a file browser, and you're going to want to go to the dev directory, which stands for devices, off the root. That's a directory with virtual entries that represent all the hardware in the computer. And what we're looking for is the serial port entries, which all start with TTY. So we'll scroll down here, and here they are. Back in the old Unix days, mainframe computers were communicated with teletypes, and that's what this stands for, teletype. But if we scroll down here with our radio plugged in, or our rig interface plugged in, we should find either TTY ACM0, which is what my ICOM 705 is creating here, or TTY USB 0. One of those two is the most common serial port devices. So I know that my serial port for my ICOM is going to be /DEV/TTY ACM0, and this is case sensitive too. So if it's USB 0, there'll be a capital USB, but TTY is lowercase. So make a note of what serial device your radio is creating. You're going to need that when we set up the connection. Next, we need to figure out what your rig type is in hamlib. So open a terminal up, and what you're going to type is rigctl space -- list. And that's going to give you a complete list of all the radio types that hamlib supports. I'm just going to hit enter here to show you. Zoom. And you can see there's a bunch of them. Look at that. They're not in any kind of alphabetical order or anything. So in order to find your radio, what we're going to do is we're going to filter the output of this command. So let me clear the screen. So we would type again rigctl -- list and a space. And what we're going to do is we're going to feed that output into another program called grep that will let us filter it for a string of characters. So we use the pipe symbol, which is the vertical bar on your keyboard, space grep, which is the filtering program, and then the string that we want to filter for. I've got an ICOM 705, so I'm going to put in 705. And that should filter out everything except the lines that have 705 in them. And yeah, okay, in this case, that's the only one that's there. So this is the hamlib entry for my ICOM 705. And this number right here at the beginning, that is the type number. So make a note of that for your radio after you find it. Now that we have the information, the serial port and the type for hamlib, we have everything that we need to set up the connection. Let's go launch Gpredict and set it up. So here we are in Gpredict. There's a little bit involved in setting this up. When you first run it, it's probably just going to have some default satellites here, and we're going to have to choose which satellites we want to see. We're also going to want to go up here to edit and update TLE data from network. The two-line element data is the data from NORAD, or not NORAD. Is it NORAD? I think it's NORAD. They track all of the space junk and all the satellites, and they provide data, orbital data, for each satellite. So if you select this, it will go out and it will download and update all of the satellite information off the internet so that your satellites are being tracked properly. It's good to do that occasionally, maybe once a week or so. And then this is the main tracking module. If we come up here to these little three-dot menus, and we come down here to configure, this is where we can edit the module to choose which satellites we want to track, and we can add a ground station with our location. I've already got Kingman, Arizona in here, but the first thing you do is you would hit add, and you would put in a name for your location, a description, And then for location, you can search and find a major city that you're in or next to or near. Or ideally, if you can look up your latitude and longitude and put them in here, you'll have a very precise location. Or you can put in the Maidenhead locator grid here and find it that way. So you'll want to edit the ground station and add your location in. And then here, select all satellites, and these are all the available satellites. And you can enter the satellite identifier for the one that you want to track. Now you can find these over on the Amsat web page, all the amateur satellites, and then they'll have an identifier like this, AO-91 or SO-50, and you'll come over here to the search term and you'll put in the one that you're looking for. If I do an AO and a dash, then these are all amateur satellites here. And you choose the one you want to track, and you just add it to the list, and then when you hit OK, it will now be tracking as well as all the other satellites here. And this is a nice little interactive display. You can come up here and right-click on a satellite, and you can show its next pass and get information on the next pass it's going to make, the time and date, the azimuth it's going to come in at, the elevation it's going to reach. This is a poor pass here. It's only going to get up to 6.28 degrees above the horizon. You can enable a ground track if you want to see, where it's going along the ground. And this one's going to make a pass close to Kingman here. 1, 2, 3 passes away. So really nice little interface here. Down here you can choose which satellite you want to monitor with this data, and this will give you all the information about where the satellite is, its altitude, its range, speed, the footprint that it covers on the ground. This one covers a footprint of 3,391 miles across, its altitude, its velocity, so on. When a satellite is coming through, it will appear here on this polar coordinate indicator, which will show its track as it moves across your area. So that'll show you which way to aim your antenna if you're using a rotator. But what we are interested in is radio control. So we have to set that up. So we're going to come up here to Edit and Preferences. And we're going to come down here to Interfaces. And this is where you're going to add an interface for control. I've already added in rigctl D here, but this is how you would do it. You'd hit Add New, and you'd give it a name, rigctl D, because it's a daemon. And then its network port. If it was on another machine, this would be the IP address, but since we're running on the same machine, it's localhost. The port number, which rigctl uses 4532, the default port number. This is the network port. Network ports are like a connection number for the network stack. If you connect to an IP address, then you can have a port, and different programs can be listening on different port numbers. They're like mailboxes on a street full of houses. And then the radio type. In this case, I'm going to be doing transceiving with the radio. So I'm going to select half duplex, because my radio is not a full duplex. It can't receive and transmit at the same time. It's one or the other. And then push-to-talk status. This is how Gpredict knows when you're transmitting. It will read the push-to-talk status from the radio. What happens is when you transmit, it will recognize that you're transmitting, and it will set the uplink frequency on the radio. So you hit push-to-talk, and then the radio will change to the uplink frequency. It's kind of clever. That way you don't need to have two VFOs and operate in split mode. You can just use a single transceiver that doesn't have two VFOs if you want. Gpredict will just notice you're transmitting, and it will change the frequency. And then you can do some additional offsets if you need to, if you want to increase or decrease the uplink or downlink frequencies here. You don't need to do that. They're going to be saved with the satellite data. We'll see that in a moment. So you set it up here, and you hit OK. And that will add this into the list of available interfaces. And I hit OK. Now I should be set up to control the radio. So I'll come up here to the little 3-bar menu here, and I'll select radio control. But wait, we don't have a way to talk to the radio yet. Oh, we didn't set up rigctl daemon. Open the terminal. Now remember how we got that information earlier, your type number and your serial device? This is where we're going to set up the man in the middle, rigctl daemon, and it's going to listen to Gpredict and talk to your radio through hamlib. So what you do is rigctl for daemon, and then we're going to put some data in. We're going to put in -m, and this will be the type number for your radio. Mine was 3085 for my ICOM. And then we're going to give it the port number, -R, and the serial port file that we looked up, /dev/tty/acm0. Optionally, you might have to enter some serial port settings, baud rate, and so on. If you have to set the baud rate for your radio, that would be -S for speed, and then the baud rate, like 9600 or 19.2 or whatever your radio is set to. If you need to set the CIV address for your radio, if it's different from the standard, that would be -C, and then the CIV address for your radio. In the case of the ICOM 705, it's automatically going to sense my baud rate, so I can just leave that alone and just hit enter right now. It looks like nothing is happening, but actually what's happening is this program is now running in the background, and it is listening and waiting for Gpredict to connect to it. So I can come back to Gpredict, and under that radio control window now, I can choose the satellite that I want to track. Let's say the ISS. And then I can choose the transponder here that I want to use. They have several different downlinks coming on, but what we're interested in here is the FM voice, which is the repeater on the ISS. This is the downlink on 2 meters, 145.8, and the uplink on 70 centimeters, 437.8. Over here, under settings, we're going to select our device, and I'm going to select that rigctl daemon that we set up. And when I hit engage, it will start tuning my radio. And I will show you in a moment how that looks on the radio. It did it. It just tuned it to 145.8. And if I come over here to track, this will start tracking the ISS and adjusting the frequency for Doppler shift, which right now is, right here you can see, -273 hertz is our Doppler shift. Watch when I hit track. Now this is the frequency that it is setting the radio to. And the uplink frequency is also being adjusted to compensate for Doppler shift. So that's what we do here to get Gpredict controlling our radio. Let me grab my camera, and I'll point it at the radio here in the screen, and I'll show you how this looks when we are tracking an active satellite. All right, I apologize for the handheld cell phone camera, but I'm going to be showing you the radio and the screen and talking about what's going on. So our next NOAA 15 is in our sky right now, but our next satellite is an amateur satellite, AO85, in 1 minute. And if I come up here to AO85 and I show next pass, I can see from the elevation it's only going to get 6 degrees above the horizon, so we're not going to be able to work it, but we'll be able to show you how this operates. If I look at the polar track, you can see it's just going to graze the horizon across the northwest. So 33 seconds until it's pass. I'm going to come up here and I'm going to select radio control, and it knows that our next satellite is AO85, so it has already selected it here, AO85. It only has one FM transponder for voice. Well, it has 2 actually. This was the current one, okay. This is going to be the uplink frequency 145, or downlink 145.9785 and uplink 435.172. I'm going to come over here to rigctl, which I still have running in the terminal, and I'm going to click engage. Now immediately my radio tuned to 145.978.5. The pass has begun. It is just at the edge of the horizon. You can see down here. I'm going to hit track, and that's going to start controlling the frequency of the radio. Now here you can see this is our Doppler corrected frequency, 145.980.20 whatever. And that's going to be slowly changing. And if we go over here and we look at the radio, you'll see that it is changing the frequency of the receiver. Now our uplink, let me switch to FM mode because this is an FM transponder. And I'll squelch that right now. We're not going to hear it because it's too close to the horizon. But if we look at our transmit frequency here, 435.167.3, and it's being corrected for Doppler as well. Let's go over here to the radio, and what I'm going to do is I'm going to take the mic and I'm going to key down to transmit and watch what happens with the frequency when I key down. Let me make sure my power is low here. Not that it matters. Like I said, we're not going to be able to hear the satellite. But when I key down, here we go. And you can see Gpredict set the frequency, the transmit frequency for us. And it's being adjusted for Doppler shift. Now if I release the push to talk, it goes back to the downlink frequency. And you can see here VFO-A. VFO is not changing. Let me go to transmit again. And it took about a half a second for it to sense the push to talk and switch to the transmit frequency. And I'll release it. And again, after a short delay, Gpredict noticed that I released the push to talk and it set our frequency back to receive. So we'll be able to work satellites with a radio that only has one VFO or no fancy features. Gpredict will simply sense that we are trying to transmit and switch the frequency. Let's do it one more time. It was almost a second, but you just have to watch. And you can see now we're transmitting. And if I release, and it switched back to receive. So that's how it works when you are tracking a satellite and you're going to try to communicate through the satellite. It will simply control your radio's frequency for you for the duration of the pass. And here we can see we've got a loss of signal in 6 minutes. But as I said, it is right down at the horizon. We're not going to be able to hear this satellite. But that's okay. I don't have the antenna that I need yet to work satellites. I'm just talking about how you control them with Gpredict, or how you control your radio with Gpredict. So I just closed Gpredict, and as you can see in our terminal, rigctl is still running. We just have the cursor over here. I'm going to type a Control-C, Control and C, which is a break signal. And there you can see our prompt came back. It exited the rigctl daemon. So that's how you would stop it. So this command string that we have to type in the terminal in order to enable that control, you might not be able to remember that. We can partially automate this whole process by creating a script that launches Gpredict and then starts this daemon for us. So I'm going to copy the line, and then I'm going to run an editor. I'm using Pluma since I'm on the Mate desktop. You would probably use some different editor. It depends on your desktop. Okay, so this is going to be a simple script that starts Gpredict and then starts the rigctl daemon for us. It won't be able to automatically close it for us. It'll leave a terminal window open. We'll still have to go into and type Control-C when we're done. But this will at least automate starting it so we don't have to remember that line. So the first thing I want it to do is I want it to run Gpredict. And I'm going to put an @ sign in here, and that means run it in the background and return control to the script. So it'll start Gpredict and the script will then continue. And the next command will be our line that starts rigctl. And I'm going to save this. And I'm going to give it a name, start sat track.sh. You could name it whatever you want. I'm just going to call it that and save it. And now I have this icon for my script. But we need to tell the operating system that this is a program that we're going to execute. So I can right-click on it and select Properties and Permissions, and I've got Allow Executing File as a Program, and I can check that here, and then this will be an executable script. Alternatively, in the terminal, we can type chmod, which means change mode, plus X, which means executable, and then the file name, /, meaning the current directory, just like that. So that's two ways that you can set that as an executable file. So now if I double click this, it's going to ask me how I want to run it. Do I want to display it in an editor? Do I want to run it? Do I want to run in terminal? We want to run it in a terminal. And there Gpredict launched. And if we go to that terminal, it looks blank, but that's because rigctl daemon was launched and is now running in the background, and we're waiting for a Control-C to exit it. So now I'm up and running. I'm ready to track with my radio. I can come up here to radio control, select rigctl-D and engage. And you can't see it because I'm not using a camera, but my radio just tuned to 145.890, so it's working. So that's how you could do that. And then when I exit Gpredict, I just have to come in here to the terminal and type a Control-C, and it goes away. So that's how you can automate launching that rigctl daemon with that line. You don't have to remember it going forward. So it's pretty straightforward. It just looks complex. I hope that this was helpful and useful for you in getting your radio set up so that rigctl and Gpredict can control the frequency while you're trying to work satellites. Now I'm going to start thinking about antennas. I'm either going to build a helical antenna or a egg beater. But I would need two. I need one for UHF and VHF. So I've got to figure all that out before I can really start working through satellites. I might even make a handheld dual band Yagi and try to just do that to follow it through the air while working the radio. We'll see. Anyway, there you go. We'll see you in the next video. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.